Everyone. Today I'm going to discuss June 2025 Unit 5 paper. So with the first question, which reaction is thermodynamically feasible under standard conditions, right? So to do this question, you need to know the E naught values of this and we know E naught values are given as reduction potentials. Therefore, I'll write the E naught values first. I'll write the equations. Ag plus with E gives Ag. And then we have V3 plus with E, V2 plus, Cu2 plus with E forming Cu plus, Zinc 2 plus with 2 electrons forming zinc, right? So these are the electrode equations we have. So if I write the electrode potentials for silver, it's plus 0.8. V3 to V2, it's minus 2.26. Cu2 plus and Cu plus, it's plus 0.15. And for zinc, it's minus 0.76, right? Then we'll see how to do this one. You can see, according to this reaction, 0 become plus 1. This is undergoing oxidation. This is undergoing reduction. So if I apply E naught, E reduction minus E oxidation, reduction 1 is vanadium, which is minus 0.26. Oxidized one is minus 0.8. You get a negative answer. So when the E naught value is negative, the reaction is not feasible. So A is not the correct answer. Then if you take B, you can see this is undergoing reduction and this is undergoing oxidation. So again, we can apply E reduction minus E oxidation. Reduction is minus 0.6. Oxidation is minus 0.15. Again, you get negative answer. So second one is also not the correct answer. If you take C, you can see iron is undergoing oxidation, vanadium is undergoing reduction. So E naught cell, E reduction minus E oxidation. Reduction is minus 0.26. Oxidation is, okay, so I didn't write the iron E naught value. So we'll see that also. For Fe3 plus becoming Fe2 plus, the value is plus 0.77, right? Minus 0.77, again you get a negative answer. So C is also wrong. So definitely D should be the answer. We'll see whether we are getting a positive value for D. E naught cell, E reduction minus E oxygen. Reduced one is vanadium, which is minus 0.26. Oxidized one is zinc, which is minus 0.76. So this will become a positive one and the positive value is greater than the negative one. So final answer, E naught value will be positive and that is thermodynamically feasible. So now you get the answer for the first question. See the second one. In a redox titration, 0.05 potassium manganate is titrated against 25 of the solution containing iron 2 ions. Mean titer of the potassium manganate is given. What color change is seen at the end point? So children, remember that initially in the conical flask, you have two ions, right? It has a pale green color. So definitely we can take the answer as pale green to pale pink, because in the conical flask, always we tell the color according to the solution in the conical flask. Iron 2 has a pale green color. When we titrate with permanganate only, when all the iron 2 plus has oxidized to Fe3 plus, the remaining color is due to the color of the permanganate, which is pink. Then the next one. What is the concentration of Fe2 plus in the solution? Right. So children, according to this, we know the concentration of permanganate and the volume of permanganate. We can easily apply C equals to N over V. Moles of per is equal to, in 1000 we have 0.05 into 18.95. To find the moles of iron 2 plus, the ratio is 1:5. So this should be multiplied by 5. Then the volume of iron is 25. Then you have to find in 1000. 1000 to 1000 will cancel out. 5, this will be 5 and this will be 0.01. Then you get the concentration as 0.018 something. 189, which is closer to 1.9. So we have two answers, 1.9. We have to see the number of decimal places correctly. So the correct answer is 1.9 into 10 to the power minus 1. What is the percentage error in a single tithe of 18.95? We know percentage uncertainty is given by uncertainty divided by the value into how many times we are using the burette into 100%. So plus or minus 0.05, value is 18.95. We use it twice into 100. So we can find the answer 0.05 divided by 18.95 into 2 into 100. So you get the correct answer as 0.527, which is closer to 0.53. Which row shows the correct changes in oxidation state? So if we take permanganate, children, right, we need to find the oxidation number. MnO4 minus, right, X plus, each oxygen is minus 2 into 4 minus 1, X is plus 7. Here it is plus 2. So the change of oxidation in manganese is plus 7 to plus 2. And iron is plus 2 to plus 3. So easily we can find the answer. Manganese plus 7 to plus 2. Iron 2 to 3. So the correct answer is D. Then the third one, which reaction occurs at the anode at an electrode in a hydrogen oxygen fuel cell? So we know it's direct theory, children. We have oxygen and water. So the correct answer is forming 4OH minus in the alkaline medium. What is the electronic configuration of zinc 2 plus? So we know zinc is 30. We can easily write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10. And this is the electronic configuration of argon. When two electrons are removing, it's removed from the outermost electron. Even though we write 3d after 4s, when you're removing electrons, we have to remove from 4s. So the correct answer is A. AR 3d10. What is the color of an aqueous solution of V2 plus? That is also direct theory. It's purple. It's given in the top in topic 17 under transition elements. Which is incorrect for H2O, OH and NH3. All can act as bidentate. Bidentate is wrong. They can act as only monodentate ligands, right? All can act as electron pair donors. That is correct. Okay, incorrect one is A. They are monodentate ligand, not bidentate. They can form covalent bonds, dative covalent bonds. They take part in complex ion formation. Those are correct. Which product forms when butyl amine reacts with ethanoyl chloride? So I'll write the two structures. Ethanoyl chloride means it's an acyl chloride. Butyl amine has 4 carbons like this. When the reaction is taking place, a condensation reaction will take place. So you get an amide, CH2, 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 CH3. So we can see that the name of the amide is written as N-butyl ethanamide because butyl group is connected to N. So N-butyl ethanamide. Which are the reagents and conditions for the reaction shown? So we can see the only change is NO2 has undergone reduction to NH2. So we need tin and concentrated HCl. Now, to answer this, you need to know from benzene how to make the diazonium salt. First, you can have benzene. Then when you add conc H2SO4, conc nitric, heat it to 60, 50 to 60, you get NO2 group, right? And then if you add tin and conc HCl and reflux, you will get NH2. For this, if you add NaNO2 HCl, and if the temperature is between 0 to 5, you get the diazonium salt. So until these are the main steps you should know when answering these type of questions, because this part is the same in both. Only difference is the change in the NO2 group to NH2. So this part you have to know. Sometimes they are given here to here, here to here, here to here, right? So you should know the reagents and the condition. At what pH would the amino acid phenylalanine have the structure shown? So you can see, children, if it is pH 2, it should be acidic. Now you can see it has protonated and deprotonated both. If it's pH 6, again it should be acidic only because it's closer to 7. It can be deprotonated as well, but these two are basic pH. Only deprotonation will take place. Therefore, the one that is slightly correct will be pH 6. And it should be the isoelectric pH of the phenylalanine, which is the repeat unit for the polymer formed from the monomers. So when you draw the polymer, children, always, if I explain what is happening, We have a carboxylic acid. And a amine. So water molecule will remove like this. So you can see from the carboxylic end OH will go, from the amine end H will go. So continuation bonds will be formed. Then you get the benzene, CO, NH, NH, and a continuation bond. So the correct structure, this is wrong because amide bond, there should be a formation of an amide bond. Amide bond is there, but there's another amide bond, it is wrong. Then what about the third effect structure? We have a carbonyl group, benzene, amide bond is there, and yeah, so C is the correct answer. If we take B, you can see two amide bonds are there, so that is also wrong. Then the next one, which is the name of the functional group that is replaced in step A. So we call it as a nitrile, CN. When there's a CN triple bond, we call it as a nitrile. What type of reaction mechanism is taking place in B? In B, you can see, children, we have a ketone. So ketones will always undergo nucleophilic addition. Aldehydes, ketones always will undergo nucleophilic addition. So these reaction mechanisms, by looking at the functional group, you should be able to tell that. In my previous videos, I have explained that if it's alkane, it will undergo free radical substitution. If it is alkene, electrophilic addition, benzene, electrophilic substitution, alkyl halide and alcohols, it can undergo nucleophilic substitution and elimination. Carboxylic acid, nucleophilic substitution. Aldehydes and ketones, nucleophilic addition. And so when after looking at the functional group, you should be able to tell the reaction mechanism. What is the percentage of carbon by mass in the final product? Okay, so they have already given the molar mass. What you should do is count the number of carbons in the final product. You can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means 120 divided by 165 into 100. So roughly you get it as 72.7. Okay, there's another question I missed. What are the reagents used in step B? So that is the nucleophilic addition of nitrile. So it should be HCN and KCN. In the mechanism, children, remember that first cyanide is coming in. The regenerated cyanide is coming from HCN. Then one, a substituted benzene compound has a general formula like this. When completely combusted, 0.025 moles compound produced 11 grams of carbon dioxide. What is the molar mass of the compound? Okay, to do this, first you need to write the equation. CN H N minus 6 in the presence of oxygen will give CO2 and H2O. then this should be N. So if you have 0.025, this is equal to 0.025 N, right? Then we know N is equal to M over MR. So 0.025 N is equal to mass is 11, molar mass 44. So that means 0.025 N is equal to 0.25. So what you should do, divide by 0.025. So if you divide it by that, you get 0.025 divided by 10. You get the number of moles as 10. That means you have to have 10 carbon atoms. So N is 10. So it should be C10H20 minus 6. Then it should be C10H20 minus 6 means 14. So 10 into 12 is 120 plus 14 would be 104. That is how you have to find the answer, right? Just always combustion equation equal the number of moles, then apply N equals M over MR to find N, right? And then we got 10. N is the number of carbon atoms. Then apply N to the formula to get the molar mass, which is very easy. Then the next one, this question alkanes. How many peaks are there in the carbon-13 spectrum of 2,2-dimethyl propane? Okay, so first we need to draw the compound to find the number of peaks. Okay, so draw the structure. Propane means there should be 3 carbon atoms. 1, 2, 3. 2,2-dimethyl means on the second carbon I should have 2 methyl groups. This is 2,2. So if you take the carbon-13 atom, children, we can see all 4 carbon atoms connected to 1 carbon atom. So that means all of them will have 1 chemical end, and there's another carbon in the middle. So both will have 2 carbon environments. So remember that even though there are more number of carbon atoms, if they are connected to the same carbon, or if there is a center of symmetry, we will always get less number of peaks in the carbon-13 NMR spectra. Then the next one, 4 students sketch the high resolution proton NMR spectrum of 2,3-dimethyl butane. Which sketch is most likely to be correct? Okay. So first I'll find the splitting pattern and the number of proton environments. Then only we can find the correct answer. Otherwise, if you try to look at the spectrum and find the answer, it's a little bit confusing, right? So first I'll draw the compound. Butane is there now. 1, 2, 3, 4, right? So we can see this particular molecule has a center of symmetry. You can divide, if you cut it, you can divide it into equal halves. So proton NMR, so we have one, these two have the same chemical environment. These two will have another chemical environment. So you have to have only two peaks. And if you take n plus 1, right? So this is attached to 3 plus quadruplet. This n plus 1, 2 plus 1, a triplet. Which species most like, okay, so anyway, then the correct answer will be, oh, sorry, that's 2, 3 dimethyl butane, right? 1, 2, 3, 4. We have to have 2, 3 dimethyl butane, something like this. CH3. Anyway, it has a center of symmetry, right? If I put the methyl group here, then you see it's identical, right? Then the number of protons will be, we have 1, and all of these will be 1, and this will be 2 because both methyl groups, so if I draw it correctly, then you can see CH3, CH3H, CH3, CH3H. So if you draw the structure, right, you can see these are connected to this one. Both of them will have one chemical environment, and there's another hydrogen too. So here also you can see the same thing, right? Then if I apply n plus 1 for A total, right, you can see that there's only one adjacent hydrogen. So 1 plus 1, it's a doublet. And you take B n 1. This has 3, 3, 6 hydrogens, right? Plus 1, it's a 7, 1, septet. So the correct answer should be B. You can see 1, 2, 3, 4, 5, 6, 7. There are 7 and doublet. The correct answer is B. So very important to draw the structure correctly. After that only, we have to find whether it has a center of symmetry or whether they are connected to the same carbon. And then only we have to find the splitting pattern. So we are done with the discussion of the MCQ, children, right?